Hello class, my name is Colby and today we'll be learning about divergent plate boundaries. Divergent boundaries actually are when the plates are moving apart. So the first thing we're going to discuss is about the plates themselves. So when it comes to these plates that shift and move, it's important to know that there are never any gaps between them and that these plates are made of crust and the lithospheric part of the mantle. This drawing right here, I know it's a really bad drawing, but it's a very crude drawing of what that all looks like. So this right here is the Continental Crust. That's the stuff I said earlier. It's made of crust and lithospheric part of the mantle. This colored here is the Oceanic Crust. These are the ones that move. So the Continental Crust moves against the Oceanic Crust. This area right here is the lithosphere. This right here is the lithospheric mantle. And this down here is the asthenosphere. I don't know if I pronounced that right, but yeah. So now let's get into divergent plates. Divergent plates are spreading boundaries. This is where new oceanic crust is created. The magma from decompression that's caused by the melting of the mantle, that becomes the hot mantle rock. And this is a picture of it. As you can see, this is the asthenosphere, the lithosphere, and as you can see, the plates are moving apart, which causes rift valleys and mid-oceanic ridges, which we'll get to later. This is an excerpt from the textbook, chapter 10, I believe. So this just talks about the spreading rate of these plates, which varies, as you can see, from 2 centimeters a year to 6 centimeters a year in the Atlantic, or in the Pacific, it could be anywhere from 12 centimeters per year to 20 centimeters per year. And these are some of the processes that take place when this is happening. Magma from the mantle pushing up to fill the voids left by divergence of the plates. Pillow lava is forming where magma is pushed out into seawater. Vertical sheeted dikes intruding into cracks resulting from the spreading, and magma cooling more slowly in the lower parts, the new crust, and forming gabbro bodies, which is a type of mafic igneous rock. And this is a picture of the process of the divergent boundary. So as you can see, the upward movement of that mantle rock, and then the zone of partial melting. So most divergent boundaries are located on oceanic ridges. As I said, the crust that's produced is mafic igneous rock. So the ridge crest is the rocks or the area around here. Don't know if y'all can see right around there, around the zone of partial melting. That is estimated to be 60 kilometers thick. The magma is about 10% of the rock's volume, and the crust that is produced after the magma flows is about 6 km thick. Like I said, they're mostly found in the oceanic ridges, and the crust is mafic igneous rock, which is this rock right here. Earthquakes and magma are commonly associated with the effects of divergent boundaries. A good example of a divergent boundary is the Pacific Ring of Fire. And another thing that does show up or correlates with divergent boundaries are normal faults. This is a picture of what a normal fault would look like on land. This is a quick little definition of normal faults. Stress at the divergent boundary pulls the hanging wall down to the relative foot wall. So As you can see here, this right here is the footwall. It's going up, and this is the hanging wall. It's going down. Now, within divergent boundaries, there are two different kinds. There is the continental rift zones, which those occur mostly on weak spots on the tectonic plates. As you can see here, that's the Rift Valley. It has some water in there. Another one is mid-oceanic rifts. Those originate on continental plates as rift zones that expand to the point of splitting plates apart, and then seawater fills that gap. So y'all can see right here that Rift Valley is getting filled with water. And this is another example of that. And these are just some pictures of what those look like. So this would be a mid-oceanic ridge. As you can see, the water's filling that up. So these separate pieces continue to drift apart, and those eventually become continents, and that process is known as rift to drift. The next thing we're going to talk about is this picture. Excuse me. So places where the continental plates are very thick, they reflect so much heat in the mantle that develops the strong currents that push the heat up to the mantle that it makes the plate softer. Then tensional forces created by this upswelling begin to pull the plate apart, and when it stretches, it becomes thinner, and that's what creates the normal faults. Eventually, these plate sections located between the faults drop into deep depressions known as rift valleys, which you can see here. That's a fault. That's a rift valley. Like I said, this is a thin continental crust. And like I said, with these normal faults, there's normally these keystone shaped blocks called downdrop, these key shaped blocks of crust known as garbin, which is right here. And then the shoulders of the garbin are called horse, which is here. So this and this is a horse, and that's the garbin in the middle. Now, when only one section drops, it's called a half garbin. But as you can see in this picture right here, these are the plates diverging right here. That's where the rift valley is created. That's the mountain range on the side of the rift valley. Then as you can see, there's the fault. There's the fault right there that helps create that rift valley. And next we're going to discuss the two different types of rifts. But before we get to that, I want to discuss more about continental rifting, which is caused by a breakup of patterns that look like the seams on a soccer ball. That's called truncated. I'll type it in here. It's called truncated I'm probably going to pronounce this wrong. Icosahedron. I don't know if I pronounced that right. So yeah, now we're going to discuss the next two, the type of rifts that are associated with divergent boundaries. So there are narrow rifts, which are categorized by a high density of active divergent boundaries, and then broad rifts have numerous fault lines but are distributed over a wide area of deformation. So an example of narrow rifts would be here, the East African Rift System. And then an example of broad rifts, let me see if I can pull this up. So an example of broad rifts is an area called the Basin region in the U.S. Let me see if I can pull up a picture of it. Basin and Range region, here it goes. So this area right here, that's an example of what broad rifts are. So in a short little wrap up, divergent boundaries are when plates are separating. It's where new oceanic crust is created. There's continental rifts and there's oceanic rifts. Continental ones are, the continental rift valleys look like this. Like I said, those are caused by that breaking pattern that we mentioned earlier, the truncated icosahedron. And those also occur on the weak points of the plate. The mid-oceanic rifts originate in continental plates as rift zones that expand. So that expands to the point of plates splitting apart and filling in the gap with seawater. And then, of course, normal faults are caused when these plates basically get so hot that they become soft, and these faults grow, normal faults grow. And we know that this depression here is called a Garben. The high rises are Horse. And then there are two types of rifts, the narrow rifts, which are found on high density active divergent boundaries, and then broad rifts, which have numerous fault lines and they're distributed over a wide area of deformation. Hope you guys enjoyed this. If there are any questions, you can find answers in your books.